Hello everyone. In the previous video we saw about what is a laser, what are the characteristics of laser, and what are the three processes that is occurring when a light interacts with the material. And we saw about population inversion. So we know that population inversion is the state of achieving more number of atoms in the excited state. With the continuation of that, now we will see about what are the components of laser and what are the types of lasers. Now, what are the components of laser that is required for the construction? The first one is a active medium, second one is a active center, and third one is a pumping method, and fourth one is a optical resonator. These four components are very much important in the construction of laser. Now we will see about what is active medium. Active medium is a medium in which population inversion takes place. Based on the medium which we are using, we are naming the laser. For example, in a ruby laser, ruby rod is the active medium. So, ruby rod, what is an active medium? Ruby rod. So, with the name of that active medium, we are giving that name to the laser. Suppose if it is a carbon dioxide laser, so carbon dioxide is the active medium. So that is why it is called as a carbon dioxide laser. So active medium is a medium in which population inversion takes place. So that medium may be a solid, liquid or gas. So what is an active center? So active center is the one in which the material in which the atoms are raised to excited state to achieve population inversion. So this is called active center. So in a carbon dioxide laser, for example, the carbon dioxide molecules are excited and they are producing the laser beam. So that is why in a carbon dioxide laser, even though we are having a mixture of gaseous molecules, carbon dioxide is called as the active center. And third important component is the pumping method. So the pumping method is an artificial method of achieving population inversion, because in natural means it is very difficult to achieve population inversion in our system. So we are using some artificial means to produce the population inversion. So by using that artificial methods, we are raising more number of atoms from ground state to excited state. So this is called pumping method. So there are several methods to achieve this population inversion, in which we can pump the atoms from the ground state to excited state. Some of the most commonly used methods are optical pumping, direct electron excitation, inelastic atom-atom collision, direct conversion and chemical process. What is optical pumping? Usually optical pumping is used in solid state lasers. So the atoms in the excited state, atoms in the ground state are excited to go to the excited state, and by using some optical sources. So the atoms are raised to excited state from ground state by absorbing a photon of energy which is coming from this optical source. So this type of pumping is called optical pumping. The electrical discharge method, we are using one cathode and anode. Usually we are using this type of pumping in gaseous lasers. So the electrons are accelerated by using very high electric field between the cathode and anode. So by the excitation, by the bombardment of high energetic electrons in that atom, so the atom in the ground state got excited because of that energy of electron, and it goes to excited state. So usually we are using this type of pumping methods in argon laser, helium neon lasers and carbon dioxide lasers. What is inelastic atom-atom collision between the atoms? So this type of pumping is used wherever we are using a mixture of gases. So inelastic atom-atom collision, we are using mixture of gases. So the electron which is coming from this cathode are made to collide with one type of atom. For example, A. So the electron will come and bombard with A, and A got excited. So this excited A atom will go and bombard with the B atom, and B got excited indirectly. So it got the energy of that electron. So this type of pumping method is called inelastic atom-atom collision between the atoms. What is direct conversion? Usually direct conversion is used in the semiconductor lasers. So in a semiconductor laser, as we know that we are having a p-type and n-type material, and there is a junction between the p-type and n-type material. So we are using a battery to move the electron from n-type to p-type. So whenever electrical energy is applied, so there is a electron from the valence band will go to the conduction band immediately. Usually this occurs in direct band gap semiconductors like gallium arsenide. So there is a combination of electron and holes takes place at the p-n junction. So now the electrical energy is converted into light energy directly. So in chemical method, usually this chemical methods type of pumping are used in dye lasers. So where is the chemical reactions that is occurring between the liquid molecules and the atoms are raised to excited state. So this type of pumping method is called chemical method. So what are the components of laser? As we said, active medium, active center, pumping method, optical resonator. So what is an optical resonator? So optical resonator acts as a feedback system in amplifying the light emitted from the active medium. So in the optical resonator, active medium is kept between the two mirrors. So one mirror is 100% reflecting and another mirror is partially reflecting. So in between those two mirrors, the active medium is kept. So when the light is emitted from the active medium, so the light photons are made to move between this partial mirror and 100% reflecting mirror. So the light undergoes multiple reflections between 100% reflecting mirror and a partial reflecting mirror. So light bounces back and forth and gives the high intense beam of laser. We can extract that intense beam of laser through this partial mirrors. So what are the types of lasers? So based on active medium used, we are having many different types of lasers. Some of them are solid state laser. So there may be a 3-level laser or 4-level laser. So 3-level laser is a ruby laser and 4-level laser we can take the example of NdOG laser. And gas laser, CO2 laser and helium neon laser. Semiconductor laser, gallium arsenide semiconductor lasers, and liquid lasers, europium benzoyl acetonate dissolved in alcohol. And this flow chart gives the how the laser light is emitted. So we are using a pumping source to pump the atoms from the ground state to excited state. In between optical resonators, we have kept this active medium. So when you are supplying an energy, active medium got excited. When the population inversion is achieved, stimulated emission will take place. By stimulated emission, amplification of light will take place, and between the optical resonator, multiple reflections undergoes, and we are getting intense beam of laser. So this is called laser, light amplification by stimulated emission of radiation. And we will see about what is a carbon dioxide laser. In a carbon dioxide laser, the active medium is mixture of carbon dioxide, nitrogen and helium. And nitrogen atoms are used to excite the carbon dioxide molecule, and the energy delivered, which is energy delivered by this nitrogen atoms, are very close to this carbon dioxide atoms. That is why nitrogen atoms are used to excite this carbon dioxide molecules. And in transitions, vibrational energy levels, the atoms are getting excited and moved in the vibration energy levels. So in carbon dioxide laser, we are talking about vibrational energy states of this molecules. So in between that vibrational states of this molecules, the carbon dioxide molecules are moving and we are getting a laser beam. So these are all the characteristics of carbon dioxide laser. So it is a 4-level molecular gas laser. An active medium is a mixture of carbon dioxide, nitrogen and helium. An active center is a carbon dioxide, and we are using electrical discharge method. Otherwise we can use inelastic atom-atom collisions too. And the pumping source is electrical power supply. And optical resonator is a gold coated metallic mirrors or aluminum coated silicon mirrors. The nature of output may be continuous or pulsed, and the output power of this carbon dioxide laser is very high. It is about 10 kilowatt, and wavelength is about 9.6 micrometer and 10.6 micrometer. So we are talking about the vibrational modes of carbon dioxide laser. So there are 3 modes of vibrations: symmetric stretching mode, bending mode and asymmetric stretching mode. So the carbon dioxide, in a carbon dioxide molecule, the carbon is at the center, and the 2 sides of carbon we are having 2 oxygen atoms. This is called CO2. In a symmetric stretching mode, the carbon dioxide which is at the center is stable, and whereas the oxygen atom at the centers, at the sides, will come towards carbon atom and leaving away. So it is moving like a spring. So this type of vibration is called symmetric stretching mode. Whereas in the bending mode, so all the atoms are under movement. When carbon atoms coming below, the oxygen atoms will go upwards. So there is always a bending between oxygen and carbon atoms. In asymmetric stretching mode, both the carbon and oxygen is under movement, whereas the oxygen moving in opposite direction to that of carbon. So in this way, the carbon dioxide molecule is moving based on the energy supply. So symmetric stretching mode, bending mode, and asymmetric stretching mode. So this is the construction of carbon dioxide laser. So we are having a quartz tube of about 5 meter long and 2.5 centimeter diameter, and the tube is filled with the gaseous mixture of carbon dioxide, nitrogen and helium with suitable partial pressures of 0.33, 1.2 and 7 mm of mercury. And we are connected this cathode and anode with the terminals connected to DC power supply, and the tube ends are with the sodium chloride Brewster's windows, so it can be used as an optical resonator, and the laser light which is generated will be polarized with the help of this sodium chloride Brewster window. And we are having a vacuum inlet, gas inlet and outlet. And what is the working of carbon dioxide laser? So the carbon dioxide molecule is moving in these three modes of vibrations: asymmetric mode, bending mode and symmetric bending mode. So in asymmetric stretching mode is denoted by 002, and bending mode is denoted by 010 and 020, and whereas symmetric mode is denoted by 100. So when you are supplying an electrical energy, first the nitrogen got excited. As the nitrogen energy of nitrogen and carbon dioxide is almost the same energy level, the nitrogen transfers its energy to that carbon dioxide molecule. So the nitrogen molecule will deliver its energy to that carbon dioxide. Because of that, carbon dioxide is getting excited. So A star denotes the nitrogen molecule in the excited state, and E denotes the electrons with higher kinetic energy, and small e is the same electron with lesser energy. So this excited nitrogen will go and collide with this carbon dioxide molecule, and carbon dioxide got excited. So carbon dioxide CO2 star denotes the carbon dioxide molecule in the excited state, and N2 denotes the nitrogen molecule in the ground state. So what are the advantages of carbon dioxide laser? Its construction is simple, and it is continuous and highly efficient, and it is high output power, and the output power is increased in extending the length of the tube. The disadvantage is that contamination of oxygen may occur because of laser action, and operating temperature may affect the efficiency of laser emission and may corrode, and accidental exposure may damage our eyes. So asymmetric stretching mode, what happens is that during working, when the excited nitrogen will come and bombard with this carbon dioxide molecule, first it got excited to the asymmetric stretching mode. When it's because of that vibrations, it may goes to symmetric mode or it may go to bending mode. When it transition takes place from asymmetric mode to bending mode, and a laser wavelength of about 9.6 micrometers is emitted. And when the transition takes place from asymmetric mode to symmetric mode, and the laser wavelength of about 10.6 micrometer will come. Okay, so this transition is most probable than that of bending to asymmetric. And what are the applications of carbon dioxide laser? Material processing like welding, drilling, cutting and soldering, we are using this carbon dioxide laser, and it is having low atmospheric attenuation. So carbon dioxide is used in open air communication, and we are using it in remote sensing, treatment of liver and lung diseases, neurosurgery and general surgery, microsurgery and bloodless operations. Thank you.